Hello and welcome to Waka Waka Breaking It Down. Today we are going over the second part of the introduction to inverse functions. So this is part two. There is a part one that we introduced before. So if you haven't done that, that should come first. So let's go right to it. Part of the introduction was just using coding, the idea being that if you send a code to someone, they should be able to uncode it so that gives the idea of an inverse, like you go one direction with the code and then you have to go backwards to uncode it. So that's kind of what this part two is about. It's kind of coding, right? So this scheme we had in part one, it was the second one. You can see it says scheme two here. So that was the second scheme that they introduced in the first part of this inverse function set. um, it was very simple. 0 goes to 0, 1 goes to 1, and then 10 was an A, 11 was a B, 12 was a C, all the way up to 35 is a Z, 36 was a period, and 37 is just a space. This isn't a hyphen, it's just a space. So that kind of, could separate your words and stuff. Okay, so that was very simple. The problem with that is it's really easy to decode. So if someone on the other end could easily, like if there was someone you didn't want to figure it out, like a spy, you didn't want them to figure it out, they could easily figure this code out and break your code, right? So how do we make it a little more complicated? Well, real codes usually have an extra step. They have some kind of key or some kind of something that they have to do to it, like they do an extra step to your code. So if you have the message "I will be there," you could change that into numbers using that what we had up here, right? So an I turns into an 18 and a W turns into 37, right? You can see here that W, oh, I take that back. The numbers, oh, that's the space, right? And then 32 is a W, right? 32, you can see a 32 would have been a W, 33 is X. Okay, so this number sequence represents this saying, I will be there. Okay, but that's too easy to break. So to make it a little more complicated, we're going to do something to all those numbers. So they're saying, well, take all your numbers and add 16 to them. And the person on the other side, the person that you want to read the message, will know when they get the message that they're supposed to undo that and that you added 16 to all the numbers before you sent it to them. So what's the sequence that your friend is going to get? Well, 18, if you add 16 to it, is going to turn into 34 right here. So we're just adding 16 to every single one of these numbers, and that's what you get here. Very simple. But now if a spy gets your code, someone that's not your friend, they would have trouble decoding this because it wouldn't be as clear to them what you did as far as the direct change, right? Because not only did you do this change, but you also added 16 to it, but they don't know that. But your friend does. So if it's your friend, so if you're decoding the formula and you're the friend and you know that I added 16 to it, what would you do to uncode this message that I sent you, right? I'm sending you this red message here. So how do you uncode that? Well, I added 16, so you might as well subtract 16 from everything, right? If you subtract 16, you'll get right back to this code that we had before. So how do we algebraically show that? Well, we can say it, subtract 16, but that's not algebraically, right? That's not what we're going for in this class. So algebraically, you're taking what was given to you, which is the x, right? And you're going to subtract 16 from all those numbers. So any particular x value, any number I gave you, you're going to subtract 16 from it, or my friend is. And that will give them that string of numbers they can use in the table, right, that we had up above. Oh, my thing's jumping around here. Now, the other thing about this is the function notation. Originally, when we have function, we use f of x. You can see that up here, right? But when we have an inverse, if I'm telling someone to go backwards, then we use this little -1 notation. You can see that little -1 up here, right? It doesn't really mean subtract by -1 or multiply by -1. It doesn't mean anything like that. It's just notation. So we use that inverse notation to show that we're going backwards. And we're not adding 16 this time, we're subtracting 16 to go backwards. Okay, so that's the idea of an inverse, right? You're going backwards. I did something going forwards, someone's going to do the same thing, but now going backwards. So what is that, right? So if you have your function is x plus 7, it's going to map, we call it mapping, x values onto y values, right? It's taking a bunch of x's, whatever x you input, it's going to output a whole bunch of y values. But if I want to undo that, what would you have to do? Well, if I added 7, I'd have to subtract 7, right? It's just going backwards. How do I write that? Well, this is how you would write the final answer. What's going on down here is they're showing you like step by step what we would do, right? So I would like to solve this if it was something more complicated. I'd have to subtract 7 from both sides, which would give you this, right? That's this guy right here. Whoops, this guy right there, right? Where you subtract 7 from both sides, and then that would be equal to x, but we would change x's and y's. So it's kind of like you would have, let me change my f of x, I'll change that into a y. And I'll just do one of these and you'll have to kind of do the rest on your own. But this is the idea. I would just subtract 7 from both sides of my equation. Then I'm going to change my x's and y's. The input now becomes the output, and the output now becomes the input because we're going backwards. So the y changes into an x, and the x changes into a y. And then the last, so you can see this equation matches what I have down here, right? Just the only difference now, the y I changed back into inverse notation. And it becomes actually more clear to your reader, because when they look at this, they don't know if this is the original function or if it's the inverse function. It's hard to figure out because it just says y. But if I show my reader and I say, hey, look, this is f of x, they're going to know that's the original function. And then when I say f negative 1 of x, they're going to know that's the inverse function, and they won't get them confused, right? These two things are related, but they're not the same. They're backwards of each other, right? So it's important. That's why we kind of use function notation so that it's very clear. This is the original function. This is the inverse function. So it's easy to see that, right? So we want to rewrite the y as f of negative 1. Okay, let me move on to the next one. So go a little faster now, right? So same thing, but now there's 2 steps. We multiplied by 2, and then we added 1. To undo it, we have to subtract 1 from both sides and then divide by 2. Or in other words, just think about what you did, right? If I put in the number 5 here, I'm going to take 2 times 5, and then I'm going to add 1. To undo that, I've got to go backwards. I got to subtract 1 first, then I have to divide by 2, right? So 2 times 5 is 10. 10 plus 1 is 11, right? 11. If I want to undo that, I have to subtract 1, right? Subtract 1 to get to 10. And then I have to divide by 2 to get back to my 5. So I'm just undoing things. Algebraically, what does that look like? Well, you subtract 1, then you take whatever you have left over and divide by 2. I mean, you're just solving though, right? Subtract 1 on both sides of the equation. Those go away. Then you're taking what you have left over, right? This g of x, blah, 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 minus 1. And then you're taking that and getting rid of this 2 on both sides, so you're dividing by 2. Sorry, that's really sloppy. But it's just like solving an equation, but you're just kind of, getting x by itself. So this x right here, right, that little x, that x is what you're solving for. And then when you get done, you're switching the x and the y's. You could, like some people, instead of like make this y right away, and then some people will just change those right off the bat. They'll say, well, let's just make this y to begin with and make this x to begin with. And I'm going to go ahead and make that change right away and do the switch right away. And then I just have to solve for y. I kind of like that because then you know that you're solving for y, because we always want y by itself, right? So that's what I will do in the future. Okay, so this is what you end up with, and you can see we've got the inverse notation, right? That's the original g of x, and then this is the inverse, where you're doing things backwards. Okay, what about this? Well, where's my x? My x is right here, right? That's my input. What am I doing to my input? Well, the first thing I'm doing is multiplying by this 3. It's kind of a negative 3, kind of. And then I'm going to add 100 to it. Remember, this is positive 100. It's not minus 100, right? It's minus 3. So I'm going to subtract, or I'm going to multiply by negative 3, and then I'm going to add 100 to it. So to go backwards, I have to subtract 100, and then I have to divide by negative 3, right? You're doing it backwards. What does that look like? It looks like this. Solving wise, I might say, well, let's change this into y. Let me switch my x and my y's right off the bat. And then I'm going to solve for y. So I'm going to subtract 100 from both sides. This is not the smoothest cursor thing in the world. And, okay. All right, so I subtracted 100, and then I have to divide by negative 3, right? You see that I'm going to divide by negative 3 to get y by itself. So divide by negative 3. Don't forget, you're dividing the whole side. You can think of it as in parentheses if you want. I kind of think of it like that. And then you have y by itself. So that is going to end up with what we have in our answers there, right here. And again, we're using inverse notation to show it's the inverse. It is not the original, which is over here. Okay, so that's the main thing. That's the whole thing. So this is just some more practice, right? Take an original function, turn it into an inverse. So what did I do here? Well, I multiplied by 3. What am I going to do to undo that? I'm going to divide by 3. Here I multiplied by 3, then I added 5. How do I undo that? Well, I subtract 5, then I divide by 3. Here I multiply by negative 3 first, then I add 7. To undo that, I have to subtract 7 and then divide by negative 3. What did I do here? Well, you can think of it as two ways. I multiplied by 3/5. You could think of it like that. I kind of think of it as I multiplied by 3 and then I divided by 5. So when you undo it, you're going to multiply by 5 and then divide by 3. That kind of undoes it, right? Now on all these, you should practice doing what I did up above where I solved, right? Where I said, let's make this y, change the function notation back into y, and then I'm going to switch my x's and my y's, and then I'm going to solve for y. So you divide by 3 on both sides, and you'll get right back to where the answer is, right? So that's what you should be practicing on all these. This is explaining, the next piece is explaining what I was just talking about. This is what I recommend, right? If you have something like this, where the function notation you can change into y, right? So that's what you see here. And I'm gonna stick with strategy 2. So I'm gonna change my function notation into y first. Then I'm gonna switch the x and the y's. Y's become x's, x's become y's, right? Because we're doing the inverse, right? Everything gets switched. We're going backwards. And then I'm gonna solve for y. So the tricky part is solving for y. So remember, this y minus 2 is kind of a group. So I have to multiply both sides of the equation by 1 of minus 2. Right? These will cancel. And then you're getting closer to what we have here. And then I'm going to divide by x. So this x is on the top here. I'm going to divide by x over on both sides. So divide by x, divide by x. So you can see the x's will cancel here, and then I'll have 5 over x. So it took a couple of steps to get to this point, right? And then I'm not done yet because x is on the bottom. Or sorry, y is not by itself yet. So I still have to add 2 to both sides to get y by itself. So that goes away, and then I have this what's left over here, right? And then the very last step is to change y back into your function notation. But remember, when you did this whole switch the x and y thing, you changed it into an inverse. So now you have an inverse function notation that you should be using. And then there's your final answer, right? It's just solving for y, getting y by itself. But honestly, people mess this up all the time because your algebra skills are not very strong. So you got to make sure you follow your algebra and all the things that you learn from algebra 1 and in geometry that you practice, right? Practicing your algebra skills and using those properly. Okay, so a little more practice down here. You can see there's a little bit of, they use different, strategy 1 is just solve first and then switch the x and y. It's no big deal. It's the same thing. Do you switch x and y in the beginning or the end? I like to switch it in the beginning so I don't forget that I'm solving for y. So here you can see they solved for x and then they switched the x and the y. And then on part B, they switched the x and the y first and then they solved for y. You should take some time to follow through with this and see step by step how they did the algebra. That's the biggest problem for people who struggle, is that your algebra skills are not strong. So then you make mistakes when you try to, like, especially when you have things like this, right? Where you have to take a whole group and multiply it over to the other side. And, some people feel like they have to distribute things in when you don't have to. So you just have to be careful. Sometimes you distribute, sometimes you don't. Just keep in mind what you're solving for, right? You're trying to get something by itself. So you want to strip things off, like divide things off or subtract things off to get that y value by itself. And then you can change it back into inverse notation. So here's another one that you can just take a gander at and look through that answer, right? You just have to go through it step by step. What did they do? Well, we switched the x and y's. I need to solve for y, so I multiply both sides by y. You can't have a y on the bottom, right? We want a y on the top. So I multiply by y on both sides, and then I divide by x, and then there you go, right? So here's some more practice. These are word problems. You're just trying to make a function, this is just logic. You just have to think it through. So you receive some money for your birthday, or Yui did, and you also they, I don't know if it's a boy or girl, works 1,000 yen per hour. So this is per hour, and we have the money saved, and then how many hours you worked. So you saved 15,000 yen just in the beginning, and Yui did. And then they also made $1,000 yen per hour. All right. So we'd have to multiply that. And that's something we're not going to tell you. You have to logically think that through. For every single hour, I'm going to get 1,000 yen. If I work 2 hours, I get 2 times 1,000, 2,000 yen. If I work 3 hours, 3 times 1,000 is 3,000 yen. And you just have to be able to logically think that through. It helps to put yourself in the situation. You should be Yui and think, okay, I have this 15,000 yen for my birthday. It's a one-time thing. And just imagine that money in your hand or in your pocket. And then you go to a job. Imagine going and doing a job and then every hour that goes by, someone's going to walk up to you and hand you 1,000 yen. And then another hour goes by and they hand you 1,000 yen. Right? You have to actually kind of, sometimes if it becomes difficult for you, put yourself in the situation and really think through step by step what would happen. And then you have to change that into algebra, right? Okay. So now we want the number of hours worked if she wants to save a particular amount of money. Now, I don't know why they used H and Z. Why are we using H and Z? Let's change those back. So, sorry, why is this? It should be S, right? H is okay, but not Z. It should be S. Okay, so what we did is just do the inverse of this. So we subtracted the 15,000 from one side to both sides. So it's S minus 15,000. You can see that on the top. And then to get rid of the 1,000, we have to divide 1,000 to both sides, which you can see ended up happening on the bottom. Okay, so then you can see that I have the original function up here, and then this is the inverse of that. And you're just saying, oh yeah, that's an inverse, right? For any particular input of H, I'm only going to get one S, and vice versa. for any particular salary I put in or savings I put in, there's only going to be one number for the number of hours that you're going to get out of it. There's not going to be two different numbers. This is a linear equation, so is this one. And linear equations are always going to be functions, right? No matter if they go up or down or whatever, they're always going to be functions. So they're inverses of each other, and the inverse is a function. Okay, this is more practice with the coding scheme, but this time is instead of doing what we did before, we're gonna do something different. We're gonna do that 3x plus 2 to the coding scheme. So to undo that, you have to subtract 2, divide by 3. So you can see that there, right? And then this is a little practice with function notation. So this, you need to make sure you understand. If it's the inverse, you can think of it in two ways. You can like directly put that into your inverse function for x, right? Because 101 would go into your inverse function. So you can see they did that here. But you could also, if you wanted, you could put this 101, that could go right here in the original function. Remember, the outputs and the inputs are switched. So the input for an inverse function, and this is really important that you understand, the input for an inverse function is the same thing as the output for the original function. You should take a minute and digest that. That's very, very important. So you can either put the 101 into the input of the inverse function, or you can make it the output of the original function. And when you solve, you'll get the same answer. You're still going to get 33 no matter what. Right? And then once you get the letter 33, or the letter that corresponds to 33, which is x, then you're done. That's your answer. That little piece right there is really important. This function notation, right? Is it f of some number? Like you're going to see down here, we have f of some number, but up here we have f inverse of some number. So really being able to decipher where that number goes in your formulas. Is it go in the original formula? If so, is it an x or a y? Does it go in the inverse function? If so, is it the x or the y? So you need to be able to kind of do that. So you need to take a minute and maybe go back over what I said. All right, so we got an original function, and then this says f of 5. This is back to what we did back in Unit 1. Okay, this is just putting 5 in for x in the original function, right? So no problem, I hope. You just stick it in, come up with a number. You can see that right here. Now we have the inverse. So like I said, if I had an inverse function, then I could just put that the 3895 into the inverse function. But I didn't make my inverse function yet. So what can we do instead? Remember, the input of an inverse is the same thing as the output of the original function because the x's and y's have been switched. So you'll see here that we don't put 3895 in for x. That's not what we do. We put it in for the y in the original function, right? If I had the inverse function in front of me, I would put it in for x, but I don't. I have the original, so I put it in for the y instead. Tricky, huh? Okay, then you can just solve, and you'll get x is 8, right? So that's 8 pounds. You gotta know what that means when you get done, right? That's the other part of this, is knowing, is the input dollars and the output is what, right? So in this case, the input is not dollars, the input is pounds, and the output is dollars. So maybe that helps you actually. So when you look at this, is 5, is that pounds or is that dollars? Well, that's pounds. So that goes in where the pounds go, which is where the x is. The f of x is in dollars. So when you see this, my brain goes, well, 38.95, that's like a price, right? That's not pounds, probably. It could be, but it's probably not. It's probably dollars. So that goes in where the dollars go, and you're actually solving for pounds, right? Solving for the inverse. Okay. That's good stuff right there. Make sure you understand it. And then finally, we do write the inverse function for that. That's the last step. So we have to subtract 1495 from both sides, right? First, I'm going to make this the x. I'm going to make this the y. and then I'm going to subtract 1495 from both sides, and then I'm going to divide the 3 to both sides. So you can see that's what they did here. We subtracted 1495 first, and then whatever you had that goes together as a group, that gets divided by 3 then. Right? You see it? Okay. All right, that's the end of the practice. That's a lot of good stuff right there. Ask questions, get help, do more practice if you need it, watch more videos.